Okay, in this tutorial we're going to be interacting with CSV files, both reading data from them and writing data to them. So to start, we need to find a suitable data set. The one we're going to start out with is going to be this one right here, which you can download through Kaggle, which is a data set about life expectancy for different countries. So on Kaggle you can see that we have 4 different attributes. We can get a little bit of a description about them. But just sort of glancing at the data, you can see that there is an associated country, which appears multiple times for several years, and then we have a value, which is the life expectancy for that country for that year. Now, knowing that isn't essential for what we're going to be doing today, but it's good to understand the data that you're working with. Okay, so we're going to go ahead and download that data. It's going to download as a zip file. We're going to extract it, but we'll actually see later a way that we can use this data in Pandas without even extracting it. But for now, we're just going to go ahead and extract it. I'm just going to close this and navigate to downloads. So I'll just extract this, and we'll see that inside we have life expectancy by country.csv. So this contains our data. Let's go ahead and take a look at that. So I'm just going to open this in LibreOffice Calc, and we can see a few things. So this is another handy thing to know. Specifically up here, LibreOffice Calc, and I'm sure Excel as well, will interpret the character set that's used. This is just the set of text characters that are used in the file. And this won't really be an issue for this particular data set. We'll look at one later where it will be important to take note of the character set. For now, we can see that it's interpreting it as this Windows 1252. That is a pretty common one. More often than that, you'll see UTF-8. Okay, so we see here that it's going to open this up, and we have our columns and then all of our data. Okay, so we're just going to close that. For convenience, I want this file to be in the same location as the Jupyter notebook that we'll be working with. So over here you can see the Get Started notebook that we created last tutorial. I'm actually just going to go ahead and create a new one in the same directory, and then we're going to move that data file over. Okay, so to create a new one, once I'm happy with the location I'm at, which is just here inside the tut folder that I created last time, I'm going to hit the plus and just create it the same way as I did previously. I'm just going to go ahead and rename this. Right, pretty happy with that. Let's go back to those folders, and now let's move that file over. So you can see the working with CSV Jupyter Notebook there. I'm going to go ahead and just drag this over. And now if I go back to the Jupyter Notebook and I click refresh, although here it's actually updated, so it is periodically refreshing, but if it doesn't show up, you can click refresh, and you should see it there. I did it through that route, but you could also click this upload button and just navigate to whichever file that you'd like to be in this location, and then just select it and open it, and it'll be placed inside this directory. Okay, so we have that in there. Let's go ahead and read in that file. So the first thing we need to do, because we'll be using Pandas to read this data in, is to import Pandas. And that's all we're going to need import-wise. Just go ahead and run that. Once that asterisk goes away, we know that it's imported. So now we're ready to read that file. So the function that we need to use from the Pandas library to read the CSV file, and specifically we're going to be reading it into a data frame object, and we'll talk a little bit later about, in another tutorial, about what a data frame object actually is and the different properties of it. But for now, just take my word. So the method we're going to be using is this one, and this is coming from the Pandas official documentation, which is really, really well maintained, and just lots of description for all of the different options that we could use, as well as, well, not on this page, but usually the methods will have really nice examples to go along with them. Right, so we're going to be using this method, and we see that we need to pass in a file path or buffer. So the way that we're going to use this method, in this case, it returns a data frame, so we need to store a reference to that. So we're going to create a variable. I'm going to call this variable df_life, standing for data frame life. And then we're going to call the pandas read CSV function. So I imported pandas as PD. I gave it the more convenient name of PD, so I'm going to use PD dot and then read CSV. So then the first argument that's passed to this function has to be the name of the CSV file. So the name of our CSV file is life expectancy by country.csv. So I'll just put that in. Right, so there are, as you can see, a lot of options that we could pass to this, and we'll be looking at some of those, but for now, we're just doing a basic load operation, which is just requiring the name of the CSV file. Okay, and then I want to take a look at that data afterward to make sure that it loaded properly. As you can see right now, it created this variable, but creating a variable doesn't produce any output in Python. It just creates the variable. So because of that, we don't see anything after that operation. So what we can do is use a method called head, and we call this on a data frame object. So remember, read CSV returns a data frame object. And so we call on that data frame object the head method. And all this does is just give you a sample of the top few entries in the data frame. So if we run this, you can see that it prints very nicely here. We have the different attributes, just like we saw whenever we looked at it in LibreOffice Calc. And we have some entries for the data. And then over here we see 0 through 4. That is the index of each of these rows, indicating basically the first or the 0th row, and 1 and 2 and so on. So this is just some of it. If we directly print the data frame, that'll also give us some output. And essentially it just takes some of the top entries, some of the bottom entries, and then just indicates that there is a lot more, but it doesn't want to overwhelm your display, so it just shows some of it. But from this, we can see that we have 15,206 rows of data and 4 columns. Okay, so we don't need to see all of this all the time, so instead I'm just going to be using the head method. Okay, so that loaded just fine. So that's all we need for a normal read, and I won't say most of the time, but given that your data is pretty simplistic and complete, this will often be all that you need. We can see that it actually pulled in the headers from the file. So the default behavior of read CSV is to actually assume that there are headers. So in the case that there aren't headers, and it assumes that there are, we'll get some weird behavior. And so we'll actually take a look at that. So I have, which will just give me a second, prepared a version of the life expectancy data that does not have any headers. So if we take a look at that in LibreOffice Calc, see that all I've done is just removed the headers. Okay, so if we were to use that file instead, and I'm just for convenience, so it's we can move a little bit faster, I'm going to put this call to head in the same cell so that it all runs at once. So if we read in that file that has no headers, just by specifying that we want to use that file rather than the original, and we run it, we can see that now the headers are the first row of data in the file, and that's not what we want. So in the case that you don't have any headers in the file, you simply need to pass another argument, another keyword argument to read CSV and tell it that there aren't any headers. So we can specify header equals none, header equals 0 would also work. Okay, so now we can see that instead of headers, our first row of data appears in the correct position, and our columns, they just have numbers as names. Alright, so let's just copy this original example. So these names, these attribute names here, those do follow a convention. Those are pretty good attribute names. You'll generally see them in one of two ways. Either lowercase with underscores. Essentially, you could kind of think of that as being valid Python-style variable naming for the attribute names. The other way that you'll see it, though, is with spaces between each of the words and capital letters for each of the words in the attribute name. If you were to prefer that style, but the file does not contain that style, then you do have an option to rename the columns. So the way that we can do that is by specifying another keyword argument called names. And I'm going to, because I may end up using several different keyword arguments, so I'm going to start using a particular style for writing out or passing multiple arguments to these functions. So anywhere you see a backslash like this, so this is one continuous Python line, and whenever I have a backslash, that tells Python that you're actually not done reading the line, even though you got to the end of the text on that line, and so it'll actually keep reading. So you can see that it snapped me down to here, and so that way I can continue to write this line. That way it doesn't stretch all the way outside of the cell and you can see everything all at once. Okay, so if I want to specify my own custom column names, I'm going to use the names keyword argument. And so there are of course several attribute names here, several different column names. So I need to pass in a list containing the same number of them if I want to rename all of these. So I'm just going to give each of these my preferred version of the name. Right, so if we run this, we can see that they now contain those particular column names. Right, so if you'd like to rename them, then you can do it in this style. However, the original naming convention is probably best. Without going into too much detail on it right now, if you have names which are valid Python variable names, then you can use another, sometimes more convenient notation for calling on a particular column in a data frame. That's something that we'll cover later, but just something to be aware of. Okay. Right, so now let's say that you actually don't want all of the data contained within a CSV file. You just want a few particular columns. Like just looking at this data here, we sort of have duplication a little bit in the form of the country name and the country code. The country code is actually enough, should be enough to identify a particular country within this data set. So we don't really need the country name. It's definitely, in a practical sense, handy to already have the country name, because that's much easier for a human to read and recognize than just the country code. But just for example, if we didn't want to include that, then I'm just going to copy down this example here, and I'm going to get rid of names because I want to use the original names. So first, let's just take a look at what that gives us. Okay, so I want to keep this column, and this column. So the way that I can do that is by passing a different keyword argument in, and that is called useCols. And it works kind of similar to names. I'm going to pass in a list, and that list is going to be the names of the columns from the data that I want to keep. So I want to keep country code, year, and value. So from this we can see that we get the same data, but excluding the country name column. Okay, so sometimes you might run into a situation where you need to skip some rows from the data file. So I've actually mocked up one that we do need to skip some rows on. Okay, so I'm just going to open this, and if we take a look at it, you can see that, and you will see this sometimes in data files where they were created by humans for humans, so they'll have several different gaps throughout the data, and you may need to just ignore those to continue on with the actual data that you're concerned with. So here, we just have the column names, and then we have these three rows that we need to skip. So that's totally fine. As you can probably guess by now, there's an argument for that. So I'm just going to close this, and I'm going to copy down this example because we'll just modify it. Get rid of useCols. Right. So the method that we need to use in order to do this, the argument that we need to use in order to do this is called skipRows. And it just accepts a list that contains, and you can also generate this list using range. But in this case, we just have an explicit number, 1, 2, 3 rows that we need to skip. So we're just going to put those in. And we also need to change to the skip rows data file. So I can see that everything looks normal. And if we take this out, you see that we just get nan rows all the way across. And so we don't want that. So we'll just leave skip rows in. And now our data looks nice like we want it to. Alright, so sometimes you'll run into another type of issue, which is a different delimiter being used for a CSV file. So CSV actually stands for comma separated values, and it means that it's a file containing several values which are delimited or separated by a comma. And then rows are delimited by a new line. So each row appears in a line, and each value within a row is just separated by a comma. So we can actually verify that if we just pick one of these CSV files. And I'm just going to do open with Notepad. So this is actually what CSV data looks like. It's just plain text. And each of the values for each of the rows is separated by a comma, as we can see, and then each row appears on a separate line. So normally you'll find that data is separated by a comma, but sometimes it won't be. And there can be several reasons for that. maybe it's old data, and so they just weren't using the comma standard. Or it could be that the data itself actually contains commas. So you might imagine a situation where there's a data file that contains, as at least part of one of the rows, an address, and it's just the entire address contained in a single cell. In that case, we would have some commas appearing after the different parts of the address. So in that situation, they might choose a different delimiter, because you want your delimiter to not appear within the data itself, because otherwise it becomes hard to read, because is this a delimiter, or is it part of the value? Okay, so I've actually prepared a file that instead of commas, it uses tabs. So this can still be read with something like LibreOffice Calc. But you can see here that we just have this one column, and it seems to contain all the data. If we click tab for our separator options, then we can see that it separates everything out nice. And if we look at this in something like Notepad, then we see that it's literally the tab character that sits in between each of these values. Okay, so if we want to read this type of file, let's just assume that it does use commas first, so we can see what that looks like. Okay, so we can see we get a mess. One column, and all of the data is just mashed into a single cell. And we can see that the tab character, which is represented as \t in Python strings. So if instead we wanted to use a tab character, then we could do that by adding another keyword argument called sep, and we specify the separator. So like I said before, in Python strings, \t is what stands for a tab, so we put \t. This is called an escaped character. It looks like it's 2 characters, but it's actually just 1, because Python interprets that as being the whitespace tab character. Okay, so if we run this, now with the proper separator, we can see that all of our data comes back as expected. Okay, so the last thing that we're going to cover regarding this dataset in this tutorial is another way of reading CSV data. So in this case, so far we've just been working directly with CSV files. However, we don't have to work with the CSV file directly. We can actually work with a compressed version of a CSV file, which might be handy if you're working on a system with limited space, or you don't want to take the time necessary to decompress that data beforehand. There could be a number of reasons. So what I'm going to do is actually just take this life expectancy file, and I am going to compress to zip. Okay, so we have a zip file here, right? And if we open this with 7-zip, we can see that it's just the CSV file inside the zip file. So the name of our zip file is just life expectancy by country.zip. I'm just going to grab that file name for later. So this is our file name, and all we need to do to read this is actually just treat it kind of the same way as the CSV files. You pass it in to read CSV, and it just interprets it correctly. So if we take a look, just to get comfortable with documentation a little bit, we have lots of different options here, and here's one called compression, and it's set to a default value of the string infer. So if we just go and find that particular argument, here it is, for on-the-fly decompression of on-data-disk, if infer and file path or buffer is path-like, then detect compression from the following extensions. So it actually works with all of these different compressed types. And then we have a special case, which we didn't get an error because we just so happen to follow it by the way that we created the example. If using zip or tar, the zip file must contain only one data file to be read in. Alright. Okay, so now to give you an example of what might happen if we had the wrong encoding selected for read CSV, we're going to use another dataset, try to read from it. So the one we'll be using is this global inflation dataset. So just navigate to this page and download that. All the links to these will be provided. Right, so once we have that, we're just going to go ahead and extract it. Okay, and we'll just copy that over to our working directory. Okay, so now to read that, I'm just going to call it EF inflation, and we're not going to do anything fancy, we're just going to read it as is. And we'll also try to display it. Okay, so this is an issue you might run into if you're restarting Jupyter Lab. So when you restart it, all the results will remain, but none of this will be run. So Pandas will not be within the current namespace. So you just need to run that. And we don't have to run the rest of these because they'll just generate the same output. That's the important one for this. So now if we run this cell, we get a different error. So if we scroll down to the bottom, we see Unicode decode error, UTF-8 codec can't decode byte, so on and so forth. Essentially, it's just telling us that read CSV tried to use the UTF-8 codec in order to decode the data that was in the file, but it was unable to. There's not a lot of great information that comes up here that can tell us how to fix this issue. Probably the best thing that we could do is to just try putting this with LibreOffice Calc or Excel, and then it tells us that it's going to import it using this character set, the Windows 1252. So if we try to use that same character set with read CSV, then it should work. So this is just the Wikipedia page about that character set. We don't need a lot of information from this, but we can see the different characters that are included. And then another name for it is CP1252. So all we have to do is go back to here, and we're going to manually specify the encoding that we're using. And the name that we need to use for it is CP1252. And so now if we tell read CSV to use that encoding rather than defaulting to UTF-8, because that's the default, then we can see that everything runs fine. Now it's a little messy. Now we, of course, have some things that need to be cleaned up, but at the very least we're getting our data in, and that's the important part for this example. Okay, so now let's try and do a little cleanup on this. This data set is a little bit wider, so I'm just going to close the File Explorer over here. Right, so we can see that we have 64 columns and 5 rows. So these look to be pretty useful. We have essentially all of the countries, and we have the country code associated with those. That's the IMF, according to the IMF, and then the country name, and just lots of different data. We have the years separated out like this. Later on, we'll probably take a look at how to represent this data in a way that's a little bit more convenient, where we'll have the years as a part of each row. So there will just be a year column rather than a column for each year. But what we're mainly focused on at this stage, reading the file, is that we want to get rid of things that aren't useful parts of the data. So these last 5 columns specifically, that's just essentially a mistake in reading the file. Okay, so to get rid of these columns, first we're just going to copy down that previous example so that we're getting our data read in. And then we're going to use the useCols keyword argument. But before, we had passed in a list containing all of the column names of the columns that we wish to keep. In this case, that would be a little bit inconvenient because there are so many columns to type in. So what we can do instead is actually specify a range of basically column indices, and those will be the columns that we want to keep, the numbers or the positions of the columns that we want to keep. So if we just want to exclude these last few, then we need to provide a range of integers that start at 0 and go to whatever the last one, the last one is over here. So we know we have 64 columns, and we have 5 that we want to get rid of. So the range that we'll want to use is 0 to 58. So we can actually use the range function rather than typing in a series of numbers in a list, which again would be more work than we really need. We can use the Python built-in range function to generate a series of values. So if I put this in, you can see it just tells us that it is a range object. But if I just turn this into a list, you can see that it's comparable to a list of values 0 all the way up to 58. So it does not include this last value, just in case you're not familiar with the Python range function. Okay, so this range is what we're going to pass in for useCols because it contains the position of all of the columns that we want to keep. Okay, so we'll just put in range 59 because it's going to be 0 up to but not including 59. And then if we run that, we can see that now it does not include those unnamed columns that only contain NaN values. Okay, so what are NaN values actually, and how do they work with read CSV? So in general, a NaN value is it could mean a lot of things depending on where it shows up. It could mean, in the context of a data set, that there simply wasn't data available. You could imagine maybe someone was jotting down sensor readings from a real-world sensor, or maybe a set of sensors. Now, there could be one day that a sensor is damaged, and so whenever it's checked to get those readings, it's not available for that particular sensor, but is available for other ones. So in that case, they might just include NaN for all of the readings that were missing. That's just one example. It really depends on the context of the data what NaN represents, or how you're supposed to interpret NaN. Now, specifically within Pandas and NumPy, there is a specific type of value, which is NaN, and that is what this is that we see in each of these spots. Now, whenever read-CSV reads in a file, it is going to look for common values that mean NaN and convert them. Now, the way that read-CSV deals with NaN values is really up to 3 different keyword arguments. Most of the time you won't have to really deal with these, but we'll still take a look at them. So these 3 keyword arguments are responsible for the behavior that read-CSV exhibits with NA. So first, the NA filter. If this is true, then NA will be processed. Essentially, NA filter controls whether or not these other 2 keyword arguments will be ignored or utilized. So basically true, enabled, false, disabled. So in the case of keep default NA, this sort of determines the behavior of the default NaN values that are interpreted and any new ones that are passed in. So we can see that there are a few different combinations. Essentially boils down to whether or not this is true or false, and whether or not NA values were passed in or not. So the default NA values are these, but you can pass in your own custom ones. So if keep default NA is true, and the NA values are specified, so this is true, and this is some set or dict or list-like of custom NA values, or just a string for a single one, then the NA values will be appended onto the default NA values, and then all of them will be used together. Now, if this is set to true, and no NA values are provided, then just the default ones are used. In the case that keep default NA is false, but NA values are specified, then only those NaN values that were provided will be used. And then finally, if keep default NA is false, and the NA values are not specified, then no strings will be parsed as NaN. So essentially, you're not converting any values to the actual NaN type. They'll just be kept as is, which it depends on how it's represented. So it may be that a dataset actually uses a number to represent NA. For instance, if an attribute is represented as a numerical value, and specifically a positive numerical value, 0 or greater, then they may use -1 in that case to represent NA. Or they may use a string, the characters NA, to represent that, or all kinds of different situations. And all of those will be maintained as is. read-CSV does do some data type conversion. It simply infers from what it sees. So if it's numerical data, then and that NaN value of -1 is not handled to be turned into the actual NaN data type, then it will just be interpreted as -1, an integer or float, depending on what the rest of the data looks like. In the case that it's NA, then it might be just interpreted as an object, which is how we'll see it stated from the data frame. But if it's a string, then it'll just show up. It'll say that it's object type, and we can see an example of that. So if I use another function called dfinfo, or sorry, .info, but we're going to do it on the inflation data frame. If I run this, we get a summary. Essentially, it's just some info about that data frame. And if you look at a few different columns and how they compare, so obviously these columns are going to be interpreted as strings as well as note. So we can see that they indicate their data type as being object. And if it's storing strings, that's what you'll see. You'll see it as object. However, the IMF country code, that was automatically interpreted by read-CSV as being a float64. The same for all of the year columns. So again, the NaN value will be interpreted in a number of different ways. And so if we actually take a look at this and indicate that we do not want it to interpret any NaN values, so we'll just use a combination of these two. We're going to set keep default NA to false, and we'll also not provide NA values. So that we'll be using this situation, which is that none of them will be parsed as nan. So first, we'll put keep default NA. And we'll just set that to false. And then we're simply not going to provide anything for NA values. Okay, so if we run this, we can see that these spots are just empty. So nothing is shown up, because before it was interpreting empty cells as nan, and so it filled those in with nan. But here, they've just been left as empty. Okay, and then we also get rid of use cols, so that we get those other columns back, the ones that we got rid of before. Again, they were empty, so they're just empty now. Okay, so now the last thing that we're going to cover is writing two CSV files. So you've read in your data, maybe you've performed a bit of cleanup on it, like we have in the case of the global dataset inflation.csv, and ready to write that out. So we'll start with the base example of global dataset of inflation.csv, and then we'll look at some different options that you can provide to it. Okay, so I'm just going to run this cell again to make sure that this is the dataset that we have, because I like having the nan values in there. So now this variable will refer to the data frame containing this data. Right, so in order to keep things condensed as I make changes, I want to be using the same data frame. I'm actually going to take this and include it in the same cell as write CSV, or whenever we write to a CSV file, so that it's consistent and we know that we're using the same data frame every time to write out, so we can see just the changes in the output. Okay, so after loading this, printing it the head, that's fine. Then we're going to use the toCSV function, and then what we have to provide to this, let me just go ahead and pull the documentation for that up. So the first thing that we have to specify is the path or buffer. This is the location that we're going to write to. So in this case, I'm just going to call it, let's see, we'll call it inflation out.csv. And so if I just provide that, I go ahead and run this. So we didn't get any output, because remember it only shows the last output. Because toCSV doesn't produce any output, there's no return value or anything like that, and we don't see anything appearing here. However, if we look over here, we can see inflation out.csv, a new file that was created seconds ago. Okay, so if I take a look at that file, all of that is fine. Right, so we can see that those name values were actually written as empty, and that's totally fine. And we can see that we just got all of our data out. But something that we didn't have before that we do have now is this column here. So that is actually the index column, and that corresponds with the index that we see here. So that is not a part of our original data. If I just open the original data file, you can see that it's not there. The default behavior is to include that index, but if we don't want to include that index, which a lot of the time you may not, then all we have to do is just add another option, and we'll see that that is removed. So on toCSV, we're going to add an option, index equals false. So now if we run this again, inflation out.csv is going to be overwritten. And if we just close the original, go to reopen it, we can see that there is no index column anymore. Okay, so from here on out, instead of opening the file here, it'll actually be a bit more convenient. We just call read CSV again, and then we can take a look at it from there. Right, so this one isn't going to show anything, so we'll just get rid of it. So we are reading from the original file, then we are writing that data frame back out to this file, and then we want to read in from the new file that we created. And I'm just going to get rid of all these options because the file that we'll be reading in has already been cleaned up. So we read in the original data, we cleaned it up a bit, and then we wrote it out to this new inflation out.csv file. So it should be that we can just read it in as is, and it should be fine. So we run this, we see that that is exactly the case. We have only those columns that we had previously selected. And additionally, we also did not have to specify the encoding being CP1252. And that's because, by default, it's going to write out in the encoding of UTF-8. So you can always start out with the original data file and then go from there. But another option that you have is to just initially, before you start your analysis, read in the file, do any sort of cleanup that you need to do along the way, and then write out the cleaned version of that file. And so now you can just choose to work with only that file, and you don't have to perform those steps to clean it up every single time. Okay, so for the next example, I'm going to use the life expectancy data. So I'm just going to go up to where we last read the original life expectancy data file, just with everything. Yep, that looks good. And I'm just going to copy that down. Okay, I'm going to set this up just like our previous example, reading in the original file, and then writing out to a new file. Now for this one, I'm just going to call it out.csv. And I'm just going to go ahead and specify that I don't want the index to be written. Right. And then we'll want to perform another read, but on our new file. So that's going to be out.csv. So we run this, see that the data looks fine. That's how we should see it. Okay. And now, if we wanted to only write out a certain set of columns, like in this case, again, we don't necessarily have to have country name alongside country code. Or you may just want to only export the data that is necessary for another calculation, or that you're going to provide to someone else. That they only need a subset of the data, particularly if you're working with an incredibly large set of data. Then it may be useful to reduce its size by getting rid of the things that aren't necessary. Okay, so in that case, if we wanted to, say, only include country code, year, and value inside of out.csv, then we'll go up to our toCSV call, and we'll just add another keyword argument called columns, and then specify a list of values, a list of the column names that we want to include. So we'll include country code, and year, and value. So now if we run this, it's written, out.csv is overwritten, and then we read it back in, and we can see that now it only includes those columns. So that could be something useful. Right, so one other thing to note is that the headers are included. You might run into a situation where you have a program that takes in a data file but assumes that there aren't headers. In that case, you would want to get rid of the headers from the data file. Now, you could just open a file and then remove the headers that way, but if this is a really, really large file, then your system may not be able to handle that much data just to open it for you to then delete a single row. So instead, what you can do, and I'll just copy this example down, and we'll just get rid of that. We'll include all of the columns. Okay, so back to our original. Now, if we don't want the headers, then we can simply add another argument and say header equals false. So now we can see that issue that we ran into before, because if we try to read it and we tell it that there are headers, whenever we call read on out.csv, then we'll find that the column names are just the first row of data. So in order to correct for that, just in our example, then we need to also add header equals none to our next read, and now everything looks fine. Alright, so now the counterpart to whenever we were using read CSV on a zip file containing a CSV file. So if we want to do the opposite of that and actually write a zip file, so write a compressed version of the CSV file, then we can do that. So the default behavior, if we just go and take a look at toCSV, you can see an option compression equals infer, and if you just go take a look at that, if infer and path or buff is path-like, then detect compression from the following extensions. So essentially it's going to use the file name that we provide in order to determine the compression that it should use, if any. Okay, so if we change the output file name to out.zip, and I'm just going to go ahead and ignore the index, and also going to keep the headers. Now we are writing to a differently named file, so we'll need to read from a differently named file. So if we run this, you see that everything shows up just fine. Now what this looks like on the disk is that we have out.zip, and if we just take a look inside of this archive, we can see that there's a file called out. So this does not include the CSV extension, but it is CSV data. If you'd like to have the extension, so out.csv be the full file name inside of the archive, then the way that we can do that is to change this from out.zip to out.csv.zip. And then the same here when we read it in. So we can see that everything reads just fine. And then if we take a look back here, we have a new file, out.csv.zip. And then if we look inside of that archive, we see out.csv. So there are, of course, a lot of options for to.csv, the same as read.csv. And you can explore more of those in the documentation. These will be fine for getting started, and it's actually a little bit more than we'll need when going through these different tutorial examples. So there are, of course, a lot of different options that can be used with the to.csv function, the same way as the read.csv function. And those can be explored further in the documentation if you're curious. This is just good enough to get us started. In addition to that, I've only covered reading and writing to CSV files, but Pandas has support for a lot of different files, as you can see just here on the side of the documentation. And we'll probably work with some of these later on, but for now, we have enough to actually move on and explore some of the other methods that we have available to us for cleaning up data or reshaping data and even performing some actual analysis on that data. Okay, so that is all for this one, and I'll see you in the next one.